right, sorry I can't be there in person today, guys, but we can still kind of quickly get through our notes today. So we're going to add on some definitions today to our big list of definitions so far, and those definitions we're going to look at today are about some angle relationships. You've probably learned about a couple of these before, but we're going to make sure we know them in our geometry context. So first one we've got here is complementary angles. Complementary angles are, by definition, two angles whose measures add up to 90 degrees. So two angles whose measures add up to 90 degrees. So if I had my two angles, another way to write this is I could say that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And that's what we'll use when we're doing proofs and such. If I know that two angles are complementary, if this was like my given, then my conclusion would be that statement that the measure of angle 1 plus measure of angle 2 is 90 degrees. And my reason would be my definition of complementary angles. Okay, so let's kind of look at some examples of how these can look. So in our other squares here, we've got what they might look like. So complementary, non-congruent, adjacent angles, right? So complementary means they add up to 90 degrees. They're non-congruent means they aren't going to be exactly the same. And adjacent means they're next to each other and they share a side. So the easiest way to draw this would be, I'm going to start with, oops, let's make that bigger. I'm going to start with my 90 degree angle. So I'm going to make myself a 90 degree angle here. We'll put the little box in here to make my 90 degree angle. And then if I just decide on some other ray to draw in here to split it, so let's say maybe here, I can make one of those angles, say this one is 60 degrees and this one is 30 degrees. Well, my 60 plus 30 is equal to 90, right? My 60 degrees, 30 degrees equals 90 degrees, so they are complementary. They're non-congruent because one's 60, one's 30, and they're adjacent because they share that side there in the middle. Okay, so that's one way you can see complementary angles. We could also have complementary congruent adjacent angles. So this time they are the same. So again, I've got my 90 degree angle here. And we'll put in the box there to make it 90 degrees. But this time I want them to be congruent. So I'm going to put my ray there right in the middle and make it a bisector. And this time our two angles would both be 45 degrees. So this time those two angles are congruent, right? They're both 45 degrees. They're adjacent because they share that side in the middle, and they're complementary because 45 degrees plus 45 degrees equals our 90 degrees. All right, and then our last set here, complementary, non-congruent, this time non-adjacent angles. So for angles to be complementary, they do not have to be right next to each other like these two pictures that we've drawn. I can have angles in two completely different pictures that are complementary. So say I've got an angle over here, and then maybe I've got another angle in a picture over here. And let's say one of these angles is 75 degrees, and this angle is 15 degrees. Well, again, my 75 plus 15 equals a total of 90 degrees, so those are complementary angles. They don't have to be right next to each other to be complementary. Okay? All right, so there's complementary. Next, we have supplementary angles. Supplementary angles are very similar, except instead of the two angles adding up to 90 degrees, this is two angles whose measures add up to 180 degrees. So two angles whose measures add up to 180 degrees. And again, we can write that as the measure of one of our angles plus the measure of the other angle equals 180 degrees. Now this is different than our linear pair postulate. Our linear pair postulate said the same thing, but in a linear pair, they have to be right next to each other. They don't have to be right next to each other for just being supplementary. Okay, so let's kind of, oh, and I have these words, they're fixed on your paper, but this should be, say, supplementary on mine. And this should also say supplementary. I believe I fixed that on your paper, but if not, fix that. Okay, so for our pictures here, first one is I want to draw supplementary, non-congruent, adjacent angles. Remember, adjacent means they have to share a side. So this, I could make my 180-degree angle there, and then give myself that. And if I said that this one is 100 degrees and this one is 80 degrees, they're supplementary because my 100 plus 80 equals the 180. They're non-congruent because one's 100 and one's 80, and they're adjacent because they share that side there, right? This is a linear pair, so it kind of works the same way. When they're supplementary and adjacent, then they are a linear pair. So they're both things there. The next one, supplementary congruent adjacent angles this time. So again, I've got my straight line, but this time I want to split it right in half to make them complementary, or I'm sorry, to make them congruent adjacent angles. And if I have 180 degrees total, if I split that in half, that means that each of these angles would have to be 90 degrees. And again, our 90 plus 90 would give us 180 degrees. They're congruent because they're both 90, and they're adjacent because they share that side in the middle. All right, and then our last one again, supplementary congruent non-adjacent angles. So again, to be supplementary, they don't have to be adjacent. They can be in two totally different pictures, or they could be in the same picture, but just not next to each other. So for example, I could have a rectangle, right? And I know that these two angles in a rectangle are both 90 degrees. So those two angles are supplementary, right? Our 90 plus 90 equals 180. They're congruent because they're both 90 degrees, and they're non-adjacent because they don't share a side. I've got these two sides and these two sides. So those are two totally different angles, non-adjacent. Okay, so different ways we can get supplementary angles. All right, then the last type of angle that we're going to use all the time, you will use these vertical angles constantly in our proofs and such that we do this semester. So a vertical angle, and a pair of vertical angles are again two angles, and we'll kind of write the definition here, and then this one's usually easier to understand once you see the picture. So a definition here is two angles whose sides, oops, I wrote the wrong letter there, angles, whose sides are opposite rays. Okay, two angles whose sides are opposite rays. Remember, opposite rays is when you've got an endpoint and then one ray goes one way and the other ray goes the other way. Okay, and it'll make more sense, like I said, when we draw our picture over here. Okay, so for vertical angles, basically what you're looking for is an X. Anytime you've got kind of an X shape in your picture like this, then we've got vertical angles. So for instance, this angle over here and this angle are a pair of vertical angles. Also, this angle and this angle are a pair of vertical angles. So it's when you've got that X shape and then it's the two angles that are kind of across from each other or opposite each other, right? Their sides, if I look at this side and this side and this side and this side, those are opposite rays if I use that center point as my common endpoint. Oops, I erased too much there. Oh, I know I erased everything. Put a line back on there. That one. And that one. There we go. Okay, so that's vertical angles. Okay, so then a couple just kind of thinking through some stuff with some sometimes, always, never. We've got a couple statements here. If I've got two right angles, meaning they're both 90 degrees, right? Those two right angles are always, sometimes, or never complementary. Well, in order to be complementary, then I've got to do an angle plus an angle has to equal 90 degrees, right? But if I'm looking at two right angles, well, I can't ever get two right angles to be complementary. That would never work, right? Because one of them is 90 degrees. I can't take one 90-degree angle, add something to it, and still get 90 degrees. If that said supplementary instead of complementary, then it would work. But that doesn't work with complementary, so that's a never. Next one, right angles are always, sometimes, or never vertical angles. So can I take this picture up here for my vertical angles, and can I make those be right angles? Well, if I think about like a coordinate plane that we draw all the time in algebra, right, where those lines are perpendicular, well, that's a right angle, and that's a right angle. So those would be vertical angles. So that's a situation where I can get right angles to be vertical. But I can also make right angles where I've got one here and I've got another one over here, right? Those are both right angles, so they're not vertical angles. So that means this one would be a sometimes, because right angles could be vertical or they could not be. Next one, angles A, B, and C are supplementary. Well, you can have three angles that add up to 180 degrees. That happens. However, if I look back at my definition here for supplementary angles, there's a key word, two. Two angles whose measures add up to 180. That's important. So if I'm talking about angles A, B, and C, they are not supplementary, and they never will be because there are three angles here, right? Sorry. In order for angles to be supplementary, we're looking at two angles only. So this would be a never. We never do three angles supplementary. All right, then our last one, vertical angles always, sometimes, or never have a common vertex. And if I look back at my picture, remember your vertical angles have to be kind of touching there in the middle. That point there in the middle is their common vertex, and they will always look like that. So vertical angles always have a common vertex. Okay. So then you're going to have some book homework that kind of deals with these definitions, and you'll see some problems that go over those. And then you've also got a worksheet with homework with some kind of story problem types or word problems where you're looking at supplementary and complementary relationships. Well, a lot of them will look similar. These two we're going to do. So the first one says the measure of one of two supplementary angles is 4 times the other. What is the measure of larger angle? Okay, so what I notice here is we're looking at two angles, and those two angles are supplementary, right? So I'm going to start with, I've got my two angles. So I'm going to just let my x represent one of the angles. Okay? So my x is one angle. Now, if I want to look at the other angle and I want to come up with something for that other angle, well, my other angle is supplementary to the first one, right? Which means that if I add the two angles together, I get 180. Well, if I have my two supplementary angles here, let's say like 180, if my first angle is 100 degrees, well, then I know my second one is 80 because I can do 180 minus 100, and I get 80. So to do that in a variable expression, if I know one angle is x, then my other angle has to be 180 minus x. Right? Okay, so there's our expressions for our two angles. Then it says that one of those angles, right? So I'm going to take one of them. So I'm going to start with my x. And then the next word is. So there's my equals. 4 times the other. So 4 times my other angle, which is 180 minus x. Right? And technically, it doesn't matter which side you put the 4 on. You could also set this up as 4x equals 180 minus x. That would also work. But either way, we'll get you the same result. You'll just get one angle before the other. Okay, so then if I want to solve this, I'm going to distribute my 4. Let's see, that's 400. That would be 720 minus 4x. And then I'm going to add 4x over, so I get 5x equals 720. And then if I divide by 5, I didn't bring my calculator. Can I do that in my head really quick? That's 1 4, and 4. There we go. Okay, so that means that one of my angles, right, is 144 degrees. And then I want to get the other angle. So I'm going to look back here. And my question is asking, what's the measure of the larger angle, right? So I know this one's 144. Well, my other angle would be 180 minus 144, which is 36, right? So then that means the measure of the larger angle is 144 degrees, right? Ta-da! Okay, let's try one more. Let's see how we do this. Or you might even kind of pause, maybe try this one on your own. Maybe you can figure this one out first and then start the video and watch my solution and see if you get the same thing. That might be a good idea, okay? Okay, so if you paused and now you're watching, to set this one up, again, I've got one of two angles, and this time they are complementary angles. So one of my angles, I'm just going to call X, and then my other angle, because they're complementary this time, I could do 90 minus X, okay? Okay, so then to set up my equation, I know one of my angles, so X, has a measure that's 20 degrees larger than the other, right? So one of my angles is 20 degrees bigger. So I'm going to say that this one's bigger. So I'm going to do X plus 20. And then that's going to be equal to my other angle, which is 90 minus X, okay? And then if I go to solve for that, I'm getting my X is on the left, so I'll get 2X plus 20 equals 90. So then 2X equals 70, which means my X is 35. Okay, and then this one asked me for what is the measure of each angle. So this time I've got to give both measurements. So if one of them is 35, then my other angle is 90 minus 35, which is 55 degrees. So then I can say the measure of the angles, I should say the measures of the angles are 35 degrees and 55 degrees. Okay, now just an FYI, if you tried either one of these, there are other ways to set up these problems. So if you set it up a different way and got the same answer, that's totally fine. Or if you want to check with me next week when I come back, we can look at these again. All right, that's it for our notes. You've got two parts to homework 4. One is the book section, and I'll pull it up here so we can see it. So it is pages 52 to 54. Make sure you go to the written exercises. Don't do the classroom exercises. And it's just 1 through 33, and you're only doing the odds this time, okay? Seems like a lot, but these are kind of just naming angles and such on a lot of these, so they go pretty quick. And we've got some algebra stuff in there as well. And as always, a proof to try to fill in, okay? And then the worksheet, we've got some of those algebra problems like we did at the end of the notes to find those, okay? And I just realized that I forgot one thing on your notes. So I'm going to go back really quick. On the vertical angles, I forgot to mention, oh, my thing's jumping all over the place here. Okay, on your vertical angles, because they're across from each other like this, vertical angles are congruent. So they always have the same measure, and we'll do some more with that next week. But for now, just know that those measures are always equal. Okay? All right, you guys have a good weekend. I will see you next week on Tuesday or Wednesday.